Say you want to build rockets like these. These rockets are built in OpenRocket, a software that includes databases of rocket parts and simulations people use to design their rockets. If you want to enter rocketry, either low or high power, learning OpenRocket is a crucial first step towards building and understanding your own rockets. If you don't have OpenRocket downloaded, search for it and download the free program from the site. Once OpenRocket is open, go to Edit, then Preferences, and change the settings to your liking. Now that your OpenRocket is set up, research the parts you'll be building with and take note of their names. If you skip this step, you might just end up with inaccurate simulations that can cause your rocket to do things like this.
Yeah, that doesn't look good.
With all your parts, input them into the software. For a low power rocket example, I'll input the body tube first by clicking the sustainer, then adding the body tube. The database shows up where I'll search for my specific part, which is a BT52 from Estes. There are a lot of parts, so you can reference the diameters and lengths to find your specific part. If you don't want to use the database, simply use the configuration tab to change the parameters. Moving on to the nose cone, you can see it's in the wrong spot. To fix this, drag the nose cone above the body tube. Double-click the nose cone to change its parameters. I'll change the base diameter to automatic so it will fit flush with the BT52. Then I'll go to the shoulder tab to create the section that couples with the tube. I'll make the diameter the same as the inner diameter of the tube and increase the length. Every rocket needs fins, so select the body tube and click Add Trapezoidal Fins. For now, the only thing I'll change is the fin cross-section and make it rounded. This is what a rounded fin looks like. A square fin and an airfoil fin. Choose the one that matches your design. The size of the motor I'll be using is an 18mm, so I need an inner tube inside of my body tube. So I'll add an inner tube and search for 18mm and find the part that matches the dimensions I want. Using the placement section of the configuration for this part, I'll move it 0.3 cm outside the body tube so the body tube does not get burned during flight. Since the inner tube is smaller than the body tube, I'll have to use centering rings to keep the inner tube in place. I'll select the inner tube and add centering rings. To be simple, I'll just choose from the database. Because these centering rings are small and not that much in length, I'll need to add 2 to ensure the inner tube is kept in place and stable. Now what goes up must come down, so you need a recovery system for your rocket. I'm just using a simple elastic shock cord and a small parachute from Estes. The purpose of the shock cord is to attach the parachute to the rest of the rocket. You want to input absolutely everything in your rocket for accurate simulations, so I will put my launch log now before I start editing my parts. You can do this by selecting the body tube and clicking the launch log, then modifying it to your preference. All of the rocket parts have been added, and now we can add the motor. Go to Motors and Configurations. Select the inner tube as a motor mount, and click on New Configuration. Go to the search bar and enter the name of your motor. For this rocket, I'll be using a C6-7. Once you find your rocket motor, make sure you go to the ejection charge delay and set it to the amount that your motor has. For me, it's 7 seconds. Finally, everything is inputted and you can see the actual data of the rocket's flight. One of the most important statistics is the stability. You want your rocket to be around 1.6 to 1.8 cal for efficient and stable rocket. If you want to use a percentage as a reference, keep the rocket around 15%, plus or minus 3 to 4%. Unstable rockets are extremely dangerous and can cause a danger to yourself and others, like this one. To change the stability, you can move the center of gravity, which is the blue dot, or move the center of pressure, which is the red dot. To move the center of gravity, you have to do things like add a mass to the top of the rocket or increase the length of the body tube. To change the location of the center of pressure, you can adjust the nose cone, the location of the motor, or the shape of the fins. I highly suggest that once you get to this part, to simply mess around with the settings and see the effects it has on the stability and apogee. For this rocket, I'll simply decrease the fin and body tube size. My rocket is fully designed with acceptable stability and apogee. To utilize all of OpenRocket's abilities, I will go to the Flight Simulations tab and run a simulation. Here you can see various velocity data, and usually you want around 15 meters per second or 50 feet per second of off-the-rod velocity and around 5 meters per second at parachute deployment. To access even more data, I can select Plot Export. Here I can plot various data like a flight side profile. This details the flight details and events. You can also look at total motion versus time to look at velocity at each event as well. Now this is all the basics of OpenRocket. There is, of course, a lot more to the software such as stages and booster pods, but this is a good starting place to build your understanding and be able to design more complex or even high power rockets. So good luck with all your rockets.